2.2, properties of exponents. We're only going to be dealing with integer exponents. For integer exponents, a is a real number. If n is a natural number, then a to the n is equal to a times a times a times a times a times a, n number of times. Right here is if I had 2 to the 5th. That just means 2 times 2 times 2 times 2 times 2. That's your n. However many that is, that's what you do. So what's 2 times 2 times 2 times 2 times 2? 2 times 2 is 4 times 2 is times 2 is times 2 is 32. So 2 to the 5th power is 32. Anything to the 0 power is automatically 1. It is not 0. If you have a negative number as an exponent, it is the inverse. If I had 2 to the negative 5th, when you have a negative exponent, all you're going to do is flip the number. So instead of 2, it now becomes 1 over 2 to the 5th. And what's 2 to the 5th? We already said 2 to the 5th is 32, so it's 1 over 32. All that a negative exponent does is makes it a fraction. Instead of being 32, it's 1 over 32. These are the basics. Now for the properties. For all of these, we're going to let a and b be non-zero real numbers. And m and n are going to be integers. The product of powers. A to the m times a to the n is a to the m plus n. Let me explain this one. If I have 2 squared times 2 squared, what's 2 squared? 4, and 4 times 4 is 16. This 2 squared actually means 2 times 2. This one means 2 times 2. How many 2's do I have? 4. This is the same thing as 2 to the 4th. You just add them up. And 2 to the 4th is 16. Just like if this was a 3 here. It's 2 there, 3 there. How many total 2's do I have? I have 5. And 2 to the 5th is 32. So if you have the same base, a and a, 2 and 2, whatever the numbers, if your bases are the same, you just add the exponents. Now if I have 3 squared times 2 to the 5th, I can't do anything with those. I can't add them together. They have to be the same base. So if I change this and made it 3 to the 5th, what's your answer? 3 to the 7th. And then I could go and figure out what 3 to the 7th is. The quotient of powers rule. If I have a to the m divided by a to the n, it's a to the m minus n. To give you numbers so you get a better understanding. If I have 5 to the 7th divided by 5 to the 4th, how many 5's are actually on top? 1, 2, 3, 4, 5, 6, 7. How many 5s are on the bottom? 1, 2, 3, 4. These are going to cancel out. What am I left with? There are 3 5s left on the top, which is just 5 to the 7th minus 4 is 5 to the 3rd. Whenever you divide exponents of the same base, you just subtract. Power of a power. A to the m to the m, or to the n, is just a to the mn. If you have an exponent to an exponent, you multiply. Let me erase this and leave me some room. I have 3 squared cubed. How many 3's are in the inside of the parentheses? There's 2. I don't know why I wrote 2. And how many of these groupings do I need? I need 3 groups of those. 3, 3, 3, 3, 3, 3. How many 3's do I have now? I have 6. Instead of writing out all the 3's, all I'm really doing is taking 2 times 3 is 6, so it's 3 to the 6th. When you have an exponent to an exponent, you multiply the exponents. The last one here. I have AB to the n. Distributive property. A to the n, B to the n. If I take this and use numbers. All right, 2 times 3. And I'll use 2 just to make it a smaller number. What's 2 times 3? 6. What's 6 squared? 36. Just to show you, when you have things on the inside of parentheses, exponents are distributive. This means 2 squared times 3 squared. What's 2 squared? 4. What's 3 squared? What's 4 times 9? 36. Now, I know some of you were thinking, why does it matter about doing this? I would just take 2 times 3 and then square it. We're not going to be dealing with numbers. You're going to have a lot of variables. And the last one is quotient. What's quotient mean? Divide. What did I do for powers when I multiplied? I multiplied, so now I'm going to. Actually, powers of quotient, when you're dividing A divided by B to the n, it's distributive also. Even though I'm multiplying, dividing, it's distributed. N goes to A, N goes to B. I want you to try this problem. I need you to simplify this expression. When you're doing these problems, the first thing I look, do I have any exponents that need distributed? Are there any exponents here that need to be distributed to numbers and variables? No. None here, none there, none there. So now I'm just going to look at the coefficients. The 2, 3, and the 5. What's 2 times 3 times 5? 2 times 3 is 6 times 5 is 30. So I'm done with the coefficients. I have 30. Now, when we write our variables, we do it alphabetically. Which comes first, the x or the z's? x. Is anything else happening to the x? So it's just x squared. Done with the x squared. Now I have a z and a z to the negative third. What do I do when I multiply things that have the same base? I add the exponents. What's the exponent really here? 1. So I'm really taking z to the 1 plus negative 3, which is, what's 1 minus 3? Z to the negative second. Where is z to the negative second? Where does that z belong? What does the negative exponent tell me? I've got to put over 1. So it actually belongs on the bottom. And that is your answer. That is all you're doing. I cannot solve this any further without knowing what numbers are. I need to know what x is. I need to know what z is. Do you understand what we're doing on this problem? Try this one. On this one, I look at my coefficients. First, does anything need distributive? Do I have any powers to powers? No, I don't have any powers to powers. Now I just look at the coefficients. I have a 3 and I have a negative 2. What's 3 times negative 2? Negative 6. You treat numbers like numbers. Don't subtract them. They're not exponents. Okay, I'm done with that. Alphabetically, what comes first? I have x squared and x cubed. X to the 5th. Why? Why x to the 5th? When I multiply, I actually add exponents. I'm done with the x's. I'm done with I have my y's. Y squared and y to the negative 4th. Again, I'm multiplying, so I need to add. What's 2 and negative 4? Now, negative 2 tells me I belong on the bottom. So on the bottom, I put y squared. That's your answer. They are just simplifying and knowing the couple rules. Try this one. What's the first thing I have to do? Distribute this 4 to every single term. Now, by doing that, I distribute up top. What do I do when I have exponents to exponents? I multiply. So I have negative y to the 28th over 2 to the 4th, z to the 48, y to the 12th. Now I'm going to worry about the numbers. This is my only number. 2 to the 4th. Now if it's a large number, like 2 to the 14th, leave it. Don't try to change it. But 2 to the 4th, 2 times 2 times 2 times 2 is 16. I'm done with that one. Alphabetically, actually I also have a negative 2. Y's come first. What do you do when you divide? Subtract. What's 28 minus 12? 16. Where do I put the y at? Y on the top. Because it's bigger. There's more y's on the top. I'm done with the y's. What am I left with? Just a z to the 48th. And that is your answer. That's one method. I'm going to show you another way. Yeah. Yep. When you have exponents to exponents, you multiply them. I'm going to show you another way as I erase that. I'm going to look inside of the parenthesis before I distribute. No number, that's fine. No other z's, that's fine. I have a negative Here's my y's. Where do I have more y's at? Top. How many more on the top? Y to the fourth. I simplified before I distributed. Now I'll distribute. Negative y to the 16th, 2 to the 4th, which means 16. Oops, I forgot my 12. And z to the 48. Both ways work. It is usually faster to simplify first before you distribute. That way you're not dealing with larger numbers, but you don't have to. Try one more. I'm not going to distribute first because I notice I have B's and I have C's the same. -3. If I look at my B's, where are there more B's at? How many more? 5 more on the bottom. So B to the 5th on the bottom. Look at my C's. Where are there more C's at? How many more on the top? 3. Now I will distribute. What's a -3 times a -3 times a -3? -27. C9. That's the way I feel. And B the 15th. That is your answer. It goes by a lot faster by simplifying ahead of time. Or you would have had B to the 6th, C to the 15th, C to the 6th, B to the 21st, and then you still simplify, you should still get the same answer. One other type that I didn't get to is the rational exponents. Rationals are just square roots. If you have something that's a fraction of an exponent, so if I had 3 to the 1/2 power, 3 to the 1/2 power just means, actually if I do 9 to the 1/2 power, that just means the square root of 9, which is 3. So if I have 1/3, that means the cube root of it. So if I had, let's see, the cube root of 125, it's what times what times what is 125? And that's 5. If there is a number that is on top, it's not 1 over. That number on the top goes on the inside of the radical. So if I had 5 to the 2/5, this actually means the 5th root of 5 squared. Let me change the number so that you can see where goes what. Let me change this to a 6. That way you can actually look in your notes and understand. So I would take 6 squared is 36, and it's the 5th root of that, which in the calculator I'll show you how to do. Questions? On the calculator, in order to do 8 to the 4/3, I do 8, caret gets me my exponent, parenthesis, 4/3. I have to put the fraction in parentheses, and it will give me this, 16. That's your answer. I could also do it 3 math number 5. That tells me it's the cube root of, I put in parentheses, 8 math cubed. I made a mistake. It should be 4. And there's no 4th. Answer 16.